In 2005, when Hurricane Katrina hit the U.S., thousands of engineers were blind for the first 48 hours. Roads vanished. Bridges collapsed. Water covered entire towns. Nobody knew which routes were open until satellites sent down high-resolution images that changed everything. Within hours, engineers mapped safe corridors, planned evacuations, and restored connectivity, all without stepping on the ground. That moment proved one truth. Civil engineering is no longer just physical, it's digital. Welcome to the Learning Studio. Today we're unlocking one of the most powerful, future-proof skills in civil engineering: GIS, remote sensing, and data analytics. For one, what is GIS? Geographic Information Systems, GIS, help engineers capture, store, analyze, and visualize spatial information. Think of it as a digital brain that understands land use, road networks, elevation maps, flood zones, utilities and pipelines, soil layers. GIS connects location with engineering decisions. It's used in urban planning, road design, water supply networks, and disaster management. Number two, what is remote sensing? Remote sensing uses satellites, drones, and aircraft to gather data without physical contact. Civil engineers use remote sensing to monitor land changes, detect water bodies, assess disaster damage, track urban growth, identify geological risks, plan transportation routes. Technologies include satellite imagery, LiDAR, laser-based 3D mapping, multispectral and hyperspectral sensors, drone photogrammetry. LiDAR is especially powerful. It can map entire cities with centimeter-level accuracy in minutes. 3. Data analytics in civil engineering. Raw data means nothing unless processed. Data analytics helps engineers convert billions of data points into meaningful decisions. Examples include predicting landslide-prone zones, estimating flood risk, mapping traffic heat zones, identifying where new roads or bridges are needed, planning drainage networks, monitoring infrastructure health. AI and ML models can detect patterns that humans can't see, making engineering solutions faster and more accurate. Real-world applications. You see these technologies every day without noticing. Google Maps routes use GIS satellite data. Smart cities use GIS for utility management. Dams and canals are monitored using satellite-based deformation data. Railway and highway alignments are planned using LiDAR terrain models. Earthquake-prone regions are mapped using remote sensing. Urban flood control is built on GIS-based hydrology models. These tools save time, cost, manpower, and, most importantly, lives. GIS, remote sensing, and data analytics are no longer optional skills. They are essential tools for every modern civil engineer, whether you work in design, planning, construction, or disaster management. Stick with this playlist, and you won't just understand maps, you'll understand the world they represent.